You are in the spotlight at least.
Maybe we should do a test first.
And it works.
To show how it works.
Well, we built this Luna mobile. It's inspired from the Google Prize X contest that private persons or persons with private funded projects could have to build a car that could drive on the surface of the moon for 500 meters and send pictures back to the Earth. So we decided to build this car and make an external remote for it. So it would be able to, we could control it in whatever way we wanted to.
I think you should turn it on.
Or sensor turnings, turn on off lights.
Oh.
Then a small test.
I think it
Make sure.
Oh. This is basically a power on self-test similar to those made by a motherboard, for example, to test that all the functions are working and just for a bit show off.
And we added some specifications on this. Yeah.
Okay, so we got the specifications of the robot. The speed is 0.7 kilometers per hour. It is measured over a track of 2 meters. Do it 5 times and take the average, and then divide by 2. So we got the maximum speed. A climbing of 2 centimeters is it's actually capable of climbing heights of at least 2 centimeters. We tested only for 2, 3 was a bit too much. And a climbing angle of 30 degrees. It is theoretically possible to cross over that step on the door with a little bit of touch and patience, but it is possible. If we would send it on the moon, we will have batteries by solar energy. Actually, Paul told us that he had some light panels that could turn on an engine. So it is possible to just add those and it will work. The low capacity, that's a little bit strange because our colleague here, Mads, during our development always offered this robot cookies. So we use it just as a transport machine. Light visibility, these lights, you are able to see them we are thinking that at least 100 meters. We've tested that lighting up here and we went all over to the end of the school and they were still visible, and that's a good thing. The next test would be to go outside and see from the window, but it was raining that day. And the blinking frequency of the lights is 20 Hertz. There's actually 20 blinkings per second of an LED. This is done using an astable multi-vibrator built in front, which is actually small circuits that make oscillations with DC current, make it act like an alternative current. This is actually a block diagram of our car. It is basically a remote control which sends information to an RCX unit which controls motor A, motor B and the lights. A little details about the remote control. We have switches. If you press one switch, we make a connection possible. The current goes through a resistance and it will send data back to the RCX. And we added these nice features, these LEDs to show up which directions are going, and for that we use a secondary power supply. And when we press the button, I think this one is
You don't have any LEDs on those two.
Oh yeah, we don't have LEDs. But this one, this is 80K, this is right. So when you press the button and the current goes through here, it will send information to go to the right. But it also it goes to this transistor, which enables to make the circuit, and the light diode will light up. This is the A-stable multi-vibrator circuit. It's actually a pretty simple circuit. The main idea is that the current oscillates from this diode to this diode. Basically, this capacitor is loading up. It's opening up this transistor, which makes the current flow through here and to light up. And when the capacitor is empty, it will close up the transistor. By that time, this capacitor will be full, which will empty this transistor and make this diode shine until it's empty C1, and all over again, repeating the cycle. Yeah. Maybe a practical presentation?
Oh yeah.
Please, go ahead.
I'm an advertiser over here. So if you like our vehicle, we would be very glad to find a sponsor. We need, let's say, approximately $20 million. would be enough to build this full-sized lunar mobile. It would be smaller because, yeah, as the Lego brick is quite big, but the real one would be smaller, not so high, and it will be able to climb, let's say, 50 degrees, and yeah, it will be able to climb all the moon surface and take the pictures, of course, and send them back. Oh yeah, and if the sponsor could give us a little more, like 30 minutes, then we won't be using any wires anymore. We will use the wireless. That's all. Thank you.
Oh, are there any questions for these guys?
Oh, there cannot be.
Please, any questions?
You said in the beginning it was going to take pictures and send back. Have you any ideas? Did you just leave it out of the equation, or?
We only took the inspiration to build the car.
Right.
Left out any other features.
What was the biggest challenge to do this project?
To limit the features?
Uh-huh.
Because we found out that we could easily put 100 different actions on one input,
Yeah.
and we have like 3 inputs, so...
Okay.
You could actually make it go more fast, but then we will lose some of the precision, and the R6 has certain limitation of the power that can give. We also have some certain ideas about how to make it faster with this gear ratio, adding some power supplies, but it was already too late to make any other.
Yeah.
But I don't think speed is an issue. I think reliability is an issue if you put something on the moon.
Yeah.
So, I think your speed is
This is
fine.
very reliable.
Okay.
Yeah.
Yeah.
Sorry.
Have you tested it in a rocket though?
Well, we're not allowed to glue it together, so I think it might just
Fall apart.
fall apart.
It's just a prototype, right? It's not what you are actually going to send up there, I suppose.
Just a prototype, yeah.
Okay. Thank you.